Okay, it's wired. It's been adjusted and tuned a little bit, and it works for the most part. But we're not out of the woods yet. But I'm not worried. I'm going to show you what we got and explain the systems and see. You guys see what you think. What we have is a 4B, which is not a outrageously powerful. It's a 100-watt flyer transformer from the early 50s, I'm guessing. And it's clipped to the track. We have the all-wheel pickup tenders. Every wheel is hot. These four wheels bring power up. These four wheels bring power up, so that's kind of neat. That power comes into what we call a power distribution board. He has a pair of rectifiers that take AC and convert it to DC. The top one has a heat sink to try to keep the heat off from building up. We do have a fan that I'll be mounting in the next piece. I don't have the hole cut or anything, but I just wired it up to make sure I had a fan. Underneath that is the motor control board. That is a clone or a remake, or I don't know what you call a repop of the Lionel 0103 digital reverse. We've found the papers on how that board was built and built a couple and then refined them for our needs as far as power ratings. Certain components are a little higher capacity. These TIP chips are a little higher rated as amp loads, such as that. So it's a little more robust than the Lionel board, which did have some notoriety for burning out on times. Okay, these clips are not part of the package. These are an option. These are for testing power out of that board. Here we have what's called a buck boost board. This is a volt regulator that can bring, if you set the voltage at 10 and you have 5 volts to the track, it will convert amps to volts and it'll send out 10. If you're up above that, say you're at 15 and you want to send out 10, it'll pull it down. And so it's kind of a buck up and a boost down, or buck down and boost up, I guess. Okay. It'll just keep it. If you set it for a voltage, it'll keep it. So this one is set at 8, and this one is also set at 8. As a stab, my first guess stab at what these systems require. This board wires into the chuff controller, and this board wires into the smoke generator, smart smoke regulator power controller, smoke controller. Pardon me, dry throat. I've been working. It regulates the heat into the coil that makes the oil vaporize, okay? Big speaker. Hardly can see it down below, but there is a soundboard that's tucked in. You can see it on this side a little easier. You see some of the capacitors and the power in and speaker out and whatnot. So that is an old TMCC soundboard. There is another option for the soundboard that I have here. This is a state-of-the-art, you can see, it's right, surface mount, digital, 1.5 watt. That will be the replacement when I run out of these boards. It will have very similar functions, 3 sounds, chuff, steam whistle, and bell. And we're working on how to get the whistle and the bell to function with or without remote, okay? Then the tender itself is 3D printed. You saw that from the one I sent to Leon. And then I don't have a body, but we got a different body because this one is, you know what? This is a royal blue. Well, nothing here is royal blue. This is all 3D printed. But it's to the chassis is a royal blue and the engine shell is a royal blue. But it's one that Leon kind of, where is it? It's not here. It's way over there somewhere. Okay, he painted it up as a tribute to the Corvette. So like the tender here is a tin tender, but you can see he's expanded it. It's an extended range royal blue. Put it that way. Extended range royal blue with next generation flyer stuff on it. That's what I'm calling it. because I don't know what else to call it. And it's this gizmo and all this. Okay, so we get up here and you'll see there is the motor with the brushes and springs and armature. All that's identical. The worm on the end, identical. The difference is the fields. They're not AC field wound. These are permanent magnet DC fields. So this motor is now a DC only. It's not a universal, and it's DC input. It's something we can control better in another way down the road. So this was sort of a step down, step up. Well, I was having field issues, and they were always so big. So I came up with this because I had field issues, didn't have enough field. So I put this on. I wanted to see if it would work, and it did. So I just started using it on all my engines. I just take the fields off, put them in a box, and put these on. Works. I've done some Northerns, some Hudsons, and this is a Royal Blue. I've done a K5, so we're putting them on lots of engines, and it seems to work well. This booster magnet on the side here is the fattest one we have. We call it the Fat Man. There's a skinny, and then there's the regular thin man, fat man, and skinny. I don't know why, but we just did it that way. In any case, this is a good magnet for this engine because it's a metal tinder, metal body on the engine. It's going to have a lot of mass to throw around, and it should do that well. This did not have the slot, as you know. This chassis looked like this, so there was no hole in here to put in our lovely gear, which we use in the Flyer, right, to get steam, puff, and the chuff sound. We don't have that. So in order to get this to work the way I wanted it to, a couple things I had to do. I had to mill this out. Before I could do that, I had to build a mill. I had this Dremel, and I found some parts online, and Andy, my dear friend in South Africa, helped me figure out, you can do this. It's not bad. We bought a Uniboard, a little board. These are drivers for the steppers. The software was shareware. It's like freeware outside. You get it. These are stepper motors that we use on our 3D printers. I put one here and one up here for the up, down, X, and Y. This is a CNC milling machine, but it's a miniature, and it's built by me. So I call it the DIY mini mill. Anyway, I use that, and I cut out the slot in this chassis here. I cut the slot out right here for that gear to sit down and run on that worm. Pretty exciting. Then on top of that gear, I have a cam. It's 2 lobes. So we're going to get every rotation 2 triggers. And what they'll trigger is one triggers a sound that goes to the soundboard, and that is a chuff sound. And the second one triggers smoke. But the smoke fan, the smoke doesn't have a piston. It has an electric motor, a little DC motor. And when that motor turns on, the puff comes out. So this will send a pulse to this motor, puff, when this is triggered. When it's not triggered, it sends a signal to the motor that says brake. It's making noise. Now I know why. It's a little loose. Okay, so this has a puff and brake capability. And when the relay of this device is energized by track power, even though there is no AC or DC, no forward and no reverse, but there is track power, then this thing will turn on an idle capability where the fan will turn on at low speed and just send up a trickle of smoke. So we have smoke running without the motor running, with track power, it's idle. And the smoke is oozing out. And I'm going to wire the firebox to that same signal. So the firebox, anytime that fan is on, the firebox is lit. So you see the orange light glow and flicker and whatnot. Okay. This smoke and this piece that it's mounted to is an adapter that I came up for this type engine. Very special adapter, bolts on, 1 screw. Doesn't need the hole, but it works now with puff and chuff. So This bolts on. This is a 3D printed smoke. Here we go. That's not it. Here's one that's closer. There you go. It's a 3D printed smoke housing. It has angel hair, a heater, a smokestack, and electric motor at the end that drives a fan inside there. It sucks air in that square hole and it blows it out. There's a hole at the top of that, blows it out, comes across here, picks up some smoke, comes across here, and then it comes out the top. You'll see that in a minute. So it's a fan-driven smoke housing for Flyer. I would say both pre-war, because I've done it already to a pre-war engine, and post, of course, the S gauge. So the O and S gauge American Flyer, this fits on it, the Fields fit on it, this will fit on it. I can make the gear, grind that out, put the gear in. All of this will fit on it. The only thing I have to change is not even the side rail. I just have to change the pivot truck inside here and widen it for O, and I already have it for S, right? So I just widen it for O, and then of course if the chassis is O, the wheels are already widened out with spacers and axles. So all of this you see here will function on any of the Flyer engines from roughly 36 to 66 or whenever. Okay, now that was reverse. We don't want to start out reverse, do we? No. Now we're in forward. Soundboard is requiring a little more juice today for some reason. At low speed, I lose the trigger, or I lose the power to the sound, so I'm going to have to work on him. At any rate, you hear the chuff sound. If you had a load, it would slow down, right? Going up a hill or whatnot. Smoke's not warm yet. It's one thing when you're running low voltage, it takes a while for it to warm up. And I run low voltage so I don't melt my smoke house. But you'll see there's smoke. So there's a pulse in the smoke as well. You hear the chuff, that means the motor's been energized. And in between chuffs, the motor has a brake and it brakes. You don't get the significance of it with a two-stroke. A four-stroke, it's impossible. We run these engines way too fast. The scale speed and everything is just all out of sight. So if you can run it slower, you get a better impression of what that is. Okay, so track is coming in with AC. It's getting converted to DC. The DC is running all these functions, and we're getting ready to see some smoke. I'm going to crank it up so the smoke gets hot in a hurry. A little slow. Am I worried? A little bit. Ow! It's hot. There it comes. I don't know if you can see it. Maybe if I get behind a black motor, then you can see the smoke. It'll build up here in a sec. Then, so that's flat out. That's about 15 volts to the motor. Oh, and this motor has a ball bearing in the front and the back of the armature. I failed to mention that. But the armature, the brushes, the brush holders, and the end cap here is all standard Flyer. The chassis is standard Flyer, except I added that little cut. Now, you should be able to verify we have smoke. You can see it, but I give you a black background, okay? Old Margaret will be on me. So I'm going to slow it down a little bit. Let's see if I can get this motor to... It's going to be hard. Without the stack and everything, it's hard for me to slow it down. Now I slowed it down too much. Lost the power to the sound. Okay, so now I'm going to come into the station and go to neutral. I don't know if you can hear it, but the smoke is, the little motor inside there is turning slowly, and it's just barely sitting out some smoke. And that helps keep the stuff cool inside, and gives you a little smoke. And you got the pop-off valve, you know, for the pressure release, popping off. And the firebox will be glowing. We've got coal we've got a fire going. We've got smoke coming out. We're waiting for the passengers, you know, now boarding, you know, track, blah, 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 and all that crap. And, the last thing I put in was a cooling fan, and it requires, it's like the sound. I'm finding my power is going down. It requires, there it goes. I know, I wasn't on it, was I? Okay, we're running, right? I have to get up to about 50%, and then it shuts right off. So I've got to either crank the volts up or check the circuit and see what's going on. I have a capacitor in circuit. God. But at any rate, this fan is what's called a blower. So it's blowing it. This is air coming out. This is where the air goes in. So what I would do is I would mount this like this. I'd have a hole in here like I do on Leon's tender for the K5, and then I would pull this. There you can see it pulls the smoke right in, blows it out the side. So it would do that. Oh, well, hopefully there's no smoke back here. That would be bad, right? But it will pull the air over the components and down, and that just a little air helps keep these babies alive a lot longer. This one gets a little, this is not too bad right now. Nobody's really super hot. Well, he gets warm, but that's what we need him to be. Oh, I rolled off my roller. Hold on a second. My rollers aren't on a rack or anything, so I gotta watch them. Oh yeah, we 3D printed these rollers. So the roller bearings themselves are from our 3D printer, but the axles and the housing we printed up. Now, and I have them in the O-gauge width as well, so if you have Lionel, you can run them. Now you can see some smoke. Now you can really see it. Takes a while to warm up. Not sure why. Maybe I put too much hair in there. I don't know. Here we are, coming down. But when you load that up and it's coming down, it really sounds great, doesn't it? Then you'd stop. You're at the station. Little lazy smoke coming up out of there. You can see it. That keeps this thing cool. This PC board's hot, and the sides of this are not hardly warm even. So we're doing that just right. So aside from the wiring menagerie, which, all right, there's 2, 4, 6, 8, 10 wires, front to rear. We got to do something about that. My biggest harness I have is 6, so I'm going to have to think this out. I think I'm going to put a slot in underneath this speaker so I can run some wires along here and up, and then bring them together in a bundle, and then push them down, and maybe I'll do like 4 on one side and 4 on the other side, and then bring them together. And I'm trying to think of a way to have that socket fixed on the engine, so that the plug is on the tender, and you just plug it in, and that you don't have to hold the 2 pieces and plug them together. That's not really that good. But, I mean, this one it may be. I do a lot of shortcuts on the early ones, and then I refine them. Like on Leon's engine, I did some what I thought were okay things, and I found later that no, you can't do that. Uh-oh. Now it stopped. I wonder what happened there. I might have touched something. Doesn't have a good connection, maybe. I don't know. All right. Well, we'll work it out. The wiring like this is a little nebulous too. I mean, things can happen to it. So you gotta be cautious. But the next step now is to build the harness, tidy this wiring up, get rid of my test points. I don't need them. Make sure I got the fan so it runs at lower speeds, and try to get the sound to stay up at lower speeds as well. And then we know the The body will fit if the wiring's not in the way. It fits on the components, but the wiring can get bulky. You got to watch it. This board's got to be put somewhere, and I put a capacitor on there, and now it doesn't fit down where I wanted it to. It might if I change it a little bit. We'll see. Okay. That's what I did. That's what I did today. I've got this running the way it's supposed to. With all my shenanigans as far as components and systems and whatnot. So this is a view of what's next generation flyer, and from my point of view, it's what I can do. It's not a Mike's Train House. It's not American models. It's all flyer based, flyer specs, standards, sizes, components. Tried to keep as much as I could. And then, okay, so why? Well, I wanted to have a Corvette train. I needed a longer tender. I made it. Now, it's not a real thing, maybe, I don't know. But what we can do is take models of engines that were not made, never made in Flyer, Gilbert, or S, and we can make them. We can give you a chassis and all the components, and you can take a body and chop it up and build what you want, or we can take 3D printed bodies that we find online and scale them for this chassis, scale them for O or S, and mount them and put them on here, and you can have engines that you don't have and would like to have. The other thing we can do is build an engine as a tribute to something. My dream is to build an engine in tribute for Snowpiercer. I think a Snowpiercer engine would be awesome. It's impossible to do with anything we have right now, but we're working on that. The other thing we want to do is take this sort of a rehash of the Gilbert tech and bring it further up. We have a Wi-Fi option for wireless that we're working on, and we're going to take 15 volts to the track DC that we're working on. So we'll be migrating up. This is what I would call level 1 next generation flyer, and then we have other stuff coming that's pretty exciting. This is all going to be put onto Thingiverse this next month or two. As I get to 1,000, I'm going to turn that thing on, and you guys can have all these prints and make them and build your own engines. I know people ask me, build me one. I'm going to do some. I have some from folks. I agreed to do them. I've had them over a year now. That's what I told them. I'm not going to get this done. They said, "Oh, it's okay." So I'll build a few, but I can't do it for everybody. And I'm hoping a lot of people would like to see this on their track running around. Not this, but with the body on it, knowing what's inside. Okay, that's it for the day. It's going on 4:30 as usual. That's when I try to button things up so I don't get in hot water with the housekeeper. Oh, gee. Okay. Talk to you next time. Keep them chugging.